Hello, everybody. This video is going to serve as a brief introduction to the Bisect method. So in particular, this video is not going to show any MATLAB code. That's going to be done in the next video. Think of this purely as just an introduction to the concepts that we're going to be implementing in our code in the future. So what is the Bisect method? It's one of the two main ways we're going to see in this class of estimating roots of functions and zeros of functions. So this one we're introducing today is called the Bisect method. And then when we get to the Python portion of the class, we're going to be talking about Newton's method. So here's the theorem. Let f of x be continuous. And suppose that fx negative is less than 0 and fx positive is greater than 0. Then there exists an x hat between x negative and x positive such that f of x hat is equal to 0. So let's kind of pick this apart, see what it's saying, and talk about, well, why is this true? And this should sound very similar to the intermediate value theorem. And in fact, it really just is the intermediate value theorem specialized to the case where we're looking for the value 0. So here I have a sketch of just some function f of x. And we can see here, we can use the intuitive kind of notion of continuity that I can kind of put my pen on the paper and trace over the function without having to lift up. So for instance, let's say here's our x plus, and you might be confused and say, Yasmin, well, why is x plus here on the left? And kind of one thing to keep in mind is x positive refers to whether or not the value of the function at that point is positive. So here we can see f of x plus is here and is positive. And we can pick, let's say, x minus down here, and we can see that f of x minus is negative. So what the theorem is saying is I can find a point where the function is positive and negative. If I know it's continuous, then I should be able to put my pen starting at the positive point, trace all the way to the negative point, and at some point it has to cross through 0. So that 0 is what we're looking for, this x hat. So what's the algorithm? How is this actually going to work? Well, let me write it down. So algorithm. The first thing we're going to do, and maybe even before I write it down, let me copy paste this picture just because it's going to help to have something to look at, and we'll add some more annotations to it as well. All right, so algorithm. First thing we're going to do is kind of define a point that we're going to start with. So we're going to call this x sub b, and this b stands for bisect. The word bisect just means to cut into two pieces. And we're going to define this to be the midpoint between the positive and the negative x values, so somewhere in the middle. So the way we're going to define that is we're going to take the average. So we take x positive, we add it to x negative, and then we divide by 2. So if I can kind of estimate here, let's see. So here's x positive, here's x negative. If I were to say halfway point, maybe it's here. So let's call this xb. And then now, so what we're writing now, remember, this is not MATLAB code. This is what's called pseudo code, where it's very close to what we want to code. It's not in perhaps the right syntax, but the ideas are all the same. So what I'm going to show you next is not something that we are going to code, but it's something that you can just think about. So I'll explain a little bit more about what I mean in just a second. So here's kind of our first step. And then second step is we have a number of if statements. So keep in mind what we're trying to do is we want xb to be a 0 of our function. So if f of xb is equal to 0, we want to output xb. Now, what's wrong with this is maybe what's not wrong, but why do we normally not kind of care so much about this step? So I'll say usually skip writing this in the code. And the reason is, think back to our videos that talk about numerical precision. it's very unlikely that we're going to find a root of our function exactly. So even if it's very, very, very close to an actual zero, checking is it equal to zero, this f of xb, it's probably not going to give us what we want. So usually skip because we don't expect to find zero exactly. We're just going to want to find a zero up to some error threshold. So kind of this first if statement is just showing you kind of ideal situation, but otherwise what we're really going to do is we're going to say, okay, if f of xb is less than zero, we're going to update the negative point. So set x negative equal to xb. Otherwise, so if f of xb is greater than zero, we're going to set x positive equal to xb. So let's see here. I'm going to switch colors just so that when we update our points, you kind of see what's going on. But here's xb. And we can see here that f of xb is greater than zero. So then what we do is this becomes the new x plus. So maybe I'll do it this way. This becomes our new x plus. And then this is a recursive process. So what it means is we just do the whole thing all over again, except now, so instead of using this x plus, we use this x plus, and we're looking between this orange x plus and this blue x minus, and we repeat the process again. So we'd say, okay, here's the distance between them. Maybe the midpoint is like here. So this becomes our new xb. And we do the process all over again. So that's fine. That's the basic idea, is we're just going to keep kind of making the interval smaller and smaller. So notice here was x plus to x minus. Then here's the new interval. And then if we were to do it again, look at this xb that's negative. So then this would be our interval. So now we just need to ask ourselves, well, when do we need to stop? When do we say, okay, we've found a point that's close enough? So there's two different ways to do that. So maybe I'll make a note of it here. So I'll call this when to stop. So two different ways. They're not equivalent, but it's not entirely, it's not super important which one you go with. So you can choose to stop when the interval is very small. So that's what we were talking about, where you repeat the process until maybe the distance between x plus and x minus is very, very narrow. Another place where you could stop is when f of xb, and we really, I guess, should put it in absolute value, is very small. So you can either stop when the interval is small or when your function evaluated at the point is very small. So in the next video, we're going to talk about how do we actually implement this in MATLAB. So thank you for watching. As always, let us know if you have any questions, and we'll see you in the next video.